In this video, I want to start looking at the tricky trig transformation worksheet that I assigned. I want to show you my thought process, and this is not the only way that you can graph these functions, but it's what makes sense to me, and that's kind of what I want to lead you through. There are other things out there. You can make a chart of points. For whatever reason, that isn't my style, so I try to adjust, and I haven't managed to do so. So on this packet, there's 6 questions, one of each type. So we've got cosine, we've got a sine problem, then we've got a secant and a cosecant, followed by a tangent and a cotangent. I want to begin, there's the cotangent, or cotangent, tangent. I want to begin with one of the secant or cosecant ones because I think they get to be the most complicated. So let me think about this for a second. If we do, okay. I'll do this secant problem because the asymptotes get confusing when we shift and when we change the period and shift left or right, which both are going to happen in this problem. So first of all, this looks a little bit confusing. If this setup bothers you, notice that this is a 1/4 times x plus pi over x plus pi, and then plus 1. So we can rewrite it that way. So you can see that this is the a value, here's the b value, the c, and the d, or sometimes we write minus c, okay, whatever. So describe the transformations. It's got a vertical stretch of 3, and so that is the one where we like to joke, where we say mind the gap. So our gap has now changed. Instead of the gap beginning at -1 and going to +1, it's now going to begin at -3 and go to +3. So it has tripled in the width of the gap. Then this one, the b value changes the period. Okay, so it's a vertical stretch of 4. I lied to you. It is a horizontal stretch of 4. And the period is this 2 pi over b. It's the period of the parent function. And since secant's parent function has a period of 2 pi over b, so this means that we have 2 pi over 1/4, which means we now have a period of 8 pi. So it's a horizontal stretch of 4, and so that gives us a period of 8 pi. And then it's going to shift left pi and up 1. Okay, so those are the transformations. Technically, when they say describe the transformations, this right here might be the actual description, but this is what the information is in our trig world. Okay, this is what's helpful information for you. Okay, so to begin with, I'm going to start with the parent function. If you don't know the parent function, you're kind of dead in the water to begin with. So you have to know the parent function. Then I'm going to do any of the stretches. Then I'm going to do the shifts. Okay, so I don't really make a table when I graph these, but I progress through this sequence. So when we have secant is cosine's buddy. So if I think about when does cosine have zeros, cosine has a 0 at -pi/2. It has a 0 at pi/2. It has a 0 at 3 pi/2. And to be honest with you, that will give us that'll give us a whole period, and that's what I'm looking for. I want to see that you can graph an entire period of this, even under the transformations. So notice that, okay, so then it has the point 0, 1, and it opens up. And maybe we should label that that's a 1, and then it's going to go as low as -1 over here at, this is pi. Okay, so what I'll be looking for is somehow you indicate, you got to tell me what this point is, you got to tell me what this point is, and you have to tell me the asymptotes. Or if you wanted to, you could start here, start at the axis, and then you'd have to tell me what this point is here that's opening up. So I want to see a complete period. It makes sense for me to do it. I like to do it this way, where I can see the entire, remember how we joked and called those Lego hands? I can see a whole Lego hand and a whole Lego hand. But if you want, you can either show me that, or you can show me this. I don't care. I just need, you'd have to label this. What is that? That becomes 2 pi. You'd have to label, I want to see either 1, 2, 3 points and 2 asymptotes, or 1, 2, 3 asymptotes and 2 points. Okay, so now we've got the stretches. So this minds the gap, and this affects our period. So everything gets pulled out by a factor of 4. So all of these asymptotes, so we now have a period. We said that our period is 8 pi, but that's hard to tell what to do when we're looking at these asymptotes. So the way I think about that is that all of these asymptotes have been pulled, they've been stretched away from the y-axis. So they've been pulled away from x equals 0 by a factor of 4. So if I multiply all of these by a factor of 4, I now have negative 2 pi, I have positive 2 pi, and then what is, okay, and then this becomes 6 pi. So what we'll do, and I'm not overly concerned about the scale. Oh, that's not a positive 2 pi, that's a negative 2 pi. And then this becomes a positive 2 pi, and then I'm going to run out of room. This becomes a 6 pi. So is this, we said that our period is now 8 pi. From here to here, is that 8 pi? It sure is, okay. And so now, this, we also have the vertical stretch, 1, 2, 3. So here's this point, and it's going to open up. And then this, 1, 2, at negative 3. And if you did little tick marks, and that's obvious that that's 3 and that's negative 3, I'm happy with that. Oh, you should label this, though. So if this is negative 2 pi, 0, 2 pi, this becomes 4 pi, 6 pi. Let me get a clean sheet of paper so that I don't try and squish this last step in that tiny little spot. Okay, so far we've done we went from the parent to the stretches, and now we have to do the shifts. So sorry, had to get a blank sheet of paper. Okay, so now what I'm doing is I'm taking this function and I'm shifting. What am I doing? I'm going left pi and up 1. Okay, so here's everything. My asymptotes, everybody has to move. Oh, you can't see it, but anyway, sorry, I'll adjust as we go. Everything has to move to the left pi, and this one we kind of got lucky that we're dealing in whole pies. It can get a little grosser than this. So what was at negative 2 pi is now at, here's 1, 2, here's negative 3 pi. Okay, here's an asymptote. We should label, oh, so sorry. We should label that as negative 3 pi. Then this was at 0. It's going to move to the left pi, so this is at pi. Let's do the asymptotes first. This one was at 1 pi. It's now at, I'm so sorry. This was at 2 pi. We're moving it to the left pi, so now we're at 1 pi. Oh, maybe I should have labeled it down below. My bad. Okay, you couldn't see any of that. Here, this is pi. And then the next one, this had been at 6 pi, move it 1 to the left, we're at 5 pi. So here's 1 pi, 2 pi, 3 pi, 1, 2, 3, 4, and here comes 5 pi is another asymptote. So I've kind of changed my scale a little bit here. But now we've got the asymptotes in place. And then these points, they had to move. Notice the moving up and down doesn't change our asymptotes. Because if I move this vertical line, or yeah, up and down, it doesn't change. So now I have to move that point up 1. I have to move it to the left pi. So I was at 0, 3. Now I'm going to move over to negative pi. And I was at 1, 2, 3, and I have to move it up 1 to 4. I'm so sorry, you can't see that. Here's negative pi. This is now positive 4, and I'm going to have a point right here. And then everything, oh, my paper got weird. Anyway, it's opening up. I'm not necessarily concerned about all those other points. I care about this point and the fact that it's opening up. Okay, the other one was here at 4 pi, negative 3. It had to shift left, so that's going to be at 3 pi. 1, 2, here's 3 pi. And then it has to shift up from negative 3, it's going to go to negative 2. So negative 1, 2, here's negative 2, here's 3 pi. Let's say I put that in the right spot. And then it's doing something like that. Okay, so we have graphed this. So now I'm always going to ask the period, the amplitude, the asymptotes, the domain, and the range. I'm always going to ask those. So the period we had said before was 8 pi. Remember how we've got that up at the top of the paper? The amplitude, this is secant. It has no amplitude, but you need to tell me that you know that it doesn't. And now when it comes to the asymptotes, they are now, if we look at this, they're 4 pi units apart. Okay, and so this is only one period of it, but it's going to repeat. But notice, the period is 8 pi, but the asymptotes split the whole period. So the asymptotes are 4 pi units apart, and then I like to, you can either tell me, pick one of them and tell me x is equal to, well, where did you start plus how far apart are they? They're 4 pi, and so that's where we put our k. This is how far apart to the next one, and then as always we say k is an element of the integers. You could say this, or you could tell me any of them. That's fine. You could tell me this one over here. I would ask you for my grading purposes if you would pick the first positive one. Okay, or if it's 0, then life is great, but pick the first positive one to tell me what the asymptotes are. All of these are fine, all of these are lovely, but I have to stop and think about these other two to make sure that what you wrote matches what I wrote. So the asymptotes, we just said x is equal to pi plus 4 pi k. I should write k's, but I ran out of space. So my domain, once again, is everything except the asymptotes. So x is not equal to pi plus 4 pi k. Pretend I wrote k's somewhere over there. And the range, okay, so what did I do? I went from negative infinity to negative 2. Pick it up again. I ran out of space. I pick it up again at 4, and I go to infinity. Okay, real fast, let me show you. Sometimes we have a situation where the numbers are a little harder to work with. I want to talk about that briefly, or no, I'm going to make another video where the numbers end up being a little grosser. So I hope this was helpful. You have to practice. The only way to learn this is to practice. So good luck to you.